Okay, thank you. So my name is Teemu Savolainen and I'm coming from Nokia CTO office to talk a little bit about the advances in IPv6 mobile access. Quite unsurprisingly, focusing more on the host point of view, but trying to remember that there are some networks that are needed to transport the data to these friendly devices. So the topics for my presentation today are the IPv6 deployment approaches in mobile access, because it's been quite topical in the last years. Very briefly, IPv6 in standards, IPv6 on handsets, what it means to have an IPv6 on a handset, status briefly on the mobile networks, changes in tethering, testing possibilities, current device if you want to have some experience, and then just briefly mentioning what one of the research topics relate to IPv6 and Wi-Fi offloading. So about deployment approaches, this has been discussed for a very long time in IT. So how do you transition from IPv4 to IPv6? Dual stack has been the main approach for years, and there has been proposals for tunneling and protocol translation and whatever. But after long discussions in 3GPP mainly, it was decided that hey, let's start the transition by having the dual stack access networks. And specifically not to have a tunneling or protocol translation, at least in the common case from handsets. So handsets start by having both V4 and V6 connectivity. The IPv6 only is another alternative that was accepted as part of 3GPP favored solutions, and V6 only meaning that there is a protocol translator, NAT64 on the network providing access to V4 only content. Of course, this can cause some problems, but that's an option for specific cases. A bit more detail about these approaches that 3GPP historically dual stack has been provided by quite similar manner as in point-to-point protocol. So there has been separate, the devices have to negotiate with networks separately, both IPv4 and IPv6 point-to-point connections up in parallel. And these are called PDP contexts. These parallel PDPs have been causing some issues, which is the reason 3GPP defined in release 8, which was released a couple of years ago, a new parent type called IPv4 v6. So this is a link layer that can transmit both IPv4 and v6 packets, uses less resources than parallel pairs, and hence is favored by quite many and seen as a great improvement, and by something that should have been defined a decade ago. The change in the link models has caused issues for hosts, especially due to the fact that the visited networks may not support v6 pair types, they may not support dual stack pair types, and when they don't support, they may fail differently. So hosts need to implement some funny fallback logics to try to get to dual stack, and if they don't, try to get parallel PDPs and may end up having only v4 connectivity. But this is pretty clear how it's to be done. So no fuss there, users don't see anything, it's just fun for the operators and handset developers. On the V6 only, the big concern and question is that if the device has V6 only connectivity, everything has to be V6 enabled on handset. It's not too big problem for the software that comes with the handset or device, but getting all third-party software to be V6 capable has proven to be somewhat challenging. Meaning all of the software you are using. If there is some software that fails, whether it can fail or not, there are some differences in opinions that let the applications fail, they will update if someone is still using it. Or the marketplace has tens of thousands of applications, someone will find a version that works with V6. You don't need to care about V4 only applications. But this is a topic where there are still discussions that whether, if the network is V6 only, whether the host should have some kind of internal IPv4 to IPv6 translator. So you could have an IPv4 only application whose communications is translate to V6 on handset, send over V6, and then on the network translate back to V4. It works for most cases, but not necessarily for all of the applications. The applications usually see that as a NAT protocol. And on the IPv6 only, the problem is that if the visited network does not support V6 pair type, then handset cannot get it, and it may need to fall back to use V4. But that is not standardized behavior, so these fallbacks from V6 only to V4 only are something that is implementation specific. But the V6 only, the world is going forward, and operators are seriously looking at that. On the standards point of view, the general message is that yes, standards are complete, let's go and implement stuff. There are some details that are being worked on, and of course new features like multi-interface improvements, mobility solutions, translations, transition tools, happy eyeballs, bug fixes, and so forth. But the message generally is that the standards are not hindering the deployment. So what the V6 means for handsets? Big thing is that the IPv6 has to be supported by the modem, and this is because I mentioned that there are these V4 and V6 and dual stack BDP types. This has to be supported by modem, so people don't realize that it's an issue because getting used to Wi-Fi's and Ethernet where you don't have this kind of dependency between IP protocols and link layers, but here we have. The modem has to support V6. TCP/IP stack has to support V6. Connection management that controls the modem has to support V6. Programming APIs on the device have to support IPv6. Applications have to support IPv6, depending a bit on the APIs they are using. And then the IPv6 support is required on the management. And this has been the huge issue, so get the reason for doing the V6. But things have been improving. So on the modem side, there has been lots of modems that have been supported by IPv4 only, but things are changing. There are vendors like Renesas, Qualcomm, ST Ericsson, GCT, Broadcom, Icera, Marvell, Infineon, Mediatek, and I guess even more, which are providing modems and they need to support V6 and IPv4 V6. It is showing red and green because not all the modems are capable yet, and if a handset is using a modem that doesn't support V6 on there, so there you go, you are V4 only. But this is improving very fast. TCP/IP stacks, well, maybe there are stacks that don't support latest RFCs, but essentially Symbian, OS X, iOS, Linux, and its derivatives like Androids, Windows, and so forth. V6 is pretty much there. And at least I don't know any handset OS that is common and would not support V6 on the stack. That's a different thing whether it's in the device, but the operating system device based on would have the stack there. Connection management, if the modem has V6 and stack has V6, but there is no way to configure the device to actually use the V6 or behave properly when roaming, that's an issue. But that is getting done as well. Programming APIs like POSIX, Qt, Java, Symbian, Silverlight, whatever you have APIs, those are pretty much V6 enabled already. I don't know any API specification that wouldn't support V6. I know some API implementations that don't support V6. And then on the APIs, the big difference is that for the application developers, that how well it hides the address family. The POSIX API or the one from Unix, that's a nasty one. The application has to explicitly be capable to use V6, and that's why the application that use these Unix-style APIs require changes. But then the modern APIs, which are present in pretty much everywhere nowadays, they allow address-agnostic functions like connect by name. If you've written application that way, it supports V6. So the applications, depending on the API, they support v6. If they are address aware, they may not like has been presented, for example, by Ariarco at least, and others. Gaming, peer-to-peer, instant messaging applications are generally a big problem, and VoIP applications, like some of the very famous ones, don't support v6 yet, and are causing issues. The management side, business case, from my point of view, it seems that that problem has been solved. So at least there's less need to sell that we need v6. Maybe there's time that do we need for this exact product, or when is the year that there's no hope to sell anything that is not v6 capable. But generally it seems that the management problem is disappearing. Hence looking good after a couple of years. So on the mobile networks then, so if the handsets are coming, how about the networks? Maybe there are people who know that there has been cellular v6 trials before 2003, but that was when I was involved first time testing v6 on cellular. 7 years after last year, there was a big US carrier that deployed v6 commercially, while many other operators were deployed, like last year, doing lab trials or some other internal trials. Other public trials and some commercial deployments on the cellular access are happening this year. Some have happened, some should occur still later this year, and lots of operators are trialing and playing out with v6. And also, I've noticed that the number of cellular v6 capable devices seem to be increasing. So handset terminal side problem is disappearing slowly, but I'm sure that by the end of next year, so 1 year from now, things are much better. I guess this means that for the networks, the v6 traffic would have good chances to start increasing. About some other technical details, tethering in the v4, you have been using dial-up, or you have been having a NAT on your handset if you have been using Wi-Fi tethering. But in v6, that changes a bit, so there are a couple of options. One is the neighbor discovery proxy, where the /64 prefix the handset gets from the cellular network is shared for the local area network, or a better way is that the handset uses DHC IPv6 prefix delegation to get some additional prefixes to be shared for this local area network, Wi-Fi usually.
Actually, one question about the previous slide, because the previous speaker talked about NT proxies in a very negative fashion. Have you actually gone through some of the recent advances in light of the access problems mentioned in Jussi's presentation? That could there be, problems looming there somewhere?
I'm not so sure this caused that problem. At least, even if the handset would proxy the neighbor discovery signaling towards the networks, the network thinks that it's a point-to-point link, so it wouldn't. I would guess that it wouldn't create any tables. Sorry? And the cellular
microphone takes a big time up.
And the cellular network probably doesn't send excess neighbor discovery messages down the pipe.
Right.
Yeah, because this neighbor discovery proxy in the moment, so you won't never have a very big network behind that. So
yeah, but the maliciousness okay, continue.
But this is proxying between a point-to-point link and multicast link, so between a very PPP style link and Ethernet. It's slightly different than having a Ethernet link where you actually use neighbor discovery. The neighbor discovery proxy is a nice feature in a way that you don't need to have a support from the network in order to number the wireless LAN without having a NAT66 or NAT66 on the device. Prefix delegation is nice, but it requires operator support. So, as I see it could very well go so that the device tries to ask for prefixes, and if it doesn't, then it does a proxy thing, and or it implements NAT66. hopefully not, but somehow I can imagine that the application vendors who make downloadable Wi-Fi hotspot applications could quite easily make them NAT66 without knowing the damage. So how to try out? I want to mention a couple of devices. I'm not so sure how many cellular operators here are, but if you want to try out in the cellular network, one is the USB stick, where you can try out, which you could use to try out these parallel IPv4, IPv6, PDP type, including these fallback logics to use parallel PDPs.
There's a link there, but the PDF probably won't have the link, so I guess I will have to incorporate it in the website later.
You can use Google to find it out. So
yeah,
just
put behind this link on Google and
What is behind the link?
It's just a fact sheet.
Can I ask, sorry, is it possible to get hold of these demo units and try them in? Because I imagine a lot of the people in the room do a lot of travelling into many countries, and often we buy a SIM card on the way in, and it would be quite a nice way of quickly checking operator support over time. Is it possible to get hold of these devices, or are they pre-engineering? Or
Now this one should be selling pretty soon. So you should be able to buy it.
So we need to swap cards.
So it's like a little right now.
As far as I know, it's as of just now, you wouldn't be able to buy one.
Joni has one in his pocket.
Yeah, and I have one. I can show you this one. Looks like.
I want one.
He works for a cellular operator. He works for a cellular operator.
Yeah, but one thing is,
If you work for a cellular operator, you might want to send it.
yeah, this is for the V4, V6 PDP type. But if you want to just try V6, you just use your Nokia phone.
Yes, you can do this one. So Symbian 3 devices and the older Symbian ones, they support so-called IPv4, IPv6 hybrid stack. And there is in this slide I mentioned that this is good to go for commercial use. So you can use it for commercial usage. The current Symbian OS has a limitation that a single application is not able to trigger activation of both V4 and V6 PDPs. So you are stuck in the V6 only mode. So you can try V6 only by placing an NAT64 and DN64 on the network and go for it.
By the way, TREX has an open-to-use, free-to-use DNS64 and NAT64 setup for testing just things like this.
But you can use that as a modem, and then you get the dual stack with PDPs.
Yeah, if you plug it with the USB to a PC and then use it as a modem, it requires a small trick.
And also,
but you can do it.
Also, I guess all of these require that your operator does actually have an IPv6 core connected to the GTSA.
Yeah, of course. But
Which is usually the trickiest part.
Yeah, but if you are a cellular operator, it's not.
Of course.
But if you are an end user, then you have just to follow your favorite operator's helpdesk and ask them.
Right.
They may ask how much do you want to pay for it.
Can I just ask, is there a list, or is there going to be a list anywhere of operators that do support these dual stack PDPs? It would be useful for, so that we know what SIMs to buy when we land in the country.
Yeah, on the dual stack IPv4 V6 PDP on commercial networks, my knowledge is that only Verizon Wireless in the US.
That's LTE.
Yeah, that's LTE.
And I guess there are also some Asian countries, but...
No, not dual stack.
No.
Oh, okay.
Okay, in 3GPP networks, so which usual GSM and wideband CDMA and LTE networks are, you have traditionally had two different connection types. So packet data protocol connection types, so PDP, V4 and V6. And this is a newer one which has them both in one connection. And some networks, well, most of them do support V4, of course, because otherwise it's really hard to get internet service. And few support V6, so you can have them at the same time, so you get the whole stack. But this new thing of having V6 and V4 in one context isn't that much better. And actually the V6 one isn't that widespread either, so some networks have it already.
So, as Dave said, a list, a whitelist or a blacklist could be useful for traveling nerds.
It's maybe better.
It's very short, the whitelist, so
yeah.
it's very short. So
And it's maybe better than somebody who's providing services or products to operators do that list, because otherwise it might affect your customer kind of like context.
Indeed.
But the fact is, there is actually quite many IPv6 networks available. I mean, several networks. You just cannot just publicly available. So
You just need to know that.
just work with your favorite telco operator and get them.
So this one was that is available for soon available, and if you need faster, you can try to contact me. The dual stack BDP. Then there is the Symbian device. You can use V6 only, and then you can modify the N900 device if you have one to support the parallel BDPs. But this one doesn't support the dual BDP. And this is the situation of today, what I want to share about our devices. On Wi-Fi, if you want to have a device on Wi-Fi, then you can pick Symbian supports dual stack on Wi-Fi. For N900, you can get dual stack. You can get iPhones support just fine. Not all Androids, but some Androids support, some Windows Mobile support, and so forth. For Wi-Fi, it's much easier. Then I guess I'm running out of time, so quickly comment that while the V6 is good to go for productization, there is some interesting stuff being researched, and what I'm mentioning here is the Wi-Fi offloading and the ICT Soft Future Internet Program, which is tackling the topic that the cellular industry is looking for means to extend overall network capacity, try to offload traffic out of cellular networks to somewhere else. And this ICT Soft Future Internet Program, work package 1, the multipath and routing evolution activity, has this kind of terminal and network interaction activity, but it's not only that, it's 3GPP, IETF, Wi-Fi, Alliance Hotspot 2.0 work. These are looking to how the Wi-Fi could be used more efficiently by the handsets. And the scenario is illustrated here quickly, that you have a device that is connected to both Wi-Fi and cellular, and then it receives rules and guidelines and policies and whatever from a network. It can get with the access network discovery and selection function, it may learn that if you are in a certain location, there are Wi-Fi networks you can use. This traffic you should try to send over Wi-Fi, or you should try to send over cellular. With DHCP-V6, it is possible to get rules like more specific IPv6 routes or DNS server selection rules, and address selection. Address selection policy rules. So whether you prefer V6 or V4, and with the router advertisements, it's also possible to deliver this kind of more specific route information. So there are different tools that could be used to inform the node that where it should actually send the traffic. And then the node, of course, receives conflicting information from different. It may receive conflicting information from Wi-Fi. Wi-Fi may send that I'm low priority. Please use cellular access, and the cellular operator may say that I'm low priority. Please offload to the Wi-Fi, and so forth. So it may result in funny conflicts. But this is one example of the stuff that is being done to improve the V6. It's like improving the network usage, improving the access selection. That was quickly. Any questions?
Okay, what's their question? Since there aren't any questions, I would like to softly thank speaker.
Yeah, I knew that Pyyhkeitä tulee.
Yeah. Actually, can you go back to the presentation slide? I just wanted to mention that about this slide. The reason why I asked him to have this slide in there as well is that TREX is sort of involved with ICT Shock as well. We provide an internet testbed, some internet testbed features for them, including the NAT64 and DNS64 service that I mentioned earlier.